Okay, this question asks us to convert these equations from exponential form to logarithmic form. Remember, the log is the inverse function to the exponential. So the first one I have here is 6 to the third equals 216. How do I write that in log form? Well, it's log base 6. The base of the exponent is the base of the logarithm. That's the first thing that you want to know. The exponent, though, goes on the right side. So the log is an exponent. Log base 6 of what? That's your other number, 216. So the way that I encourage students to remember this is to circle the base, 6 to the exponent, 6 to the third equals 216. So it's easier to think of it this way, but that's our process. The base of the exponent is the base of the log, and the exponent is on the right side. That's what you want to keep in mind. Our next question is 7 to the x equals 150. So what's the base? Where does that go? What's the exponent? Where does that go? How do we make sense of this? Well, again, log base, what base 7? The exponent is on the right side, and the argument of that log function will be 150. Again, to check it, we circle the exponent. Check that, we circle the base. Base to the exponent, 7 to the x equals 150, and that checks. What is our next question? We have 10 to the 5th equals 100,000. Well, there's an added thing here. The base goes on the left. Log base what? Log base 10. The base goes on the left. The exponent is after the equal sign. Again, exponent on the right side. And the argument, 100,000, goes here. And the way you check that is you circle the base, 10, to the 5 equals 100,000. Now, there's one other thing I need to say, is that if it's log base 10, we don't have to write that. So if you see this, if you see log 100,000, that means log base 10 of 100,000. And let me show you on the calculator what happens there. So I have, notice log 10 is really log base 10 of 10 is 1, because 10 to the first power is 10. Log base 10 of 100 is 2, because 10 to the second is 100. The question we just did was log of 100,000. Here's LOG. You see LOG, that is log base 10, 100,000. Log base 10 of 100,000 should equal 5 based on what we did. And it does. That's correct. So our next question is 3 to the 0 equals 1. How do we write that? 3 to the 0 equals 1. Log base what? The base of the exponent is the base of the logarithm. The exponent is on the right, and the argument is what's left. So the base is 3. 3, circle the base. 3 to the 0 equals the argument equals 1. 3 to the 0 equals 1 is my way to check that. All right, what's next? B to the 1 equals B. Okay. So how do we write that as an exponential? Excuse me, as a logarithmic. B to the 1 equals B. So log base, the base of the exponential is the base of the log. the exponent goes on the other side, and then the argument goes here. So it's log base b of b is 1. So log base b of b is 1. B to the first power is b is how we check that, which is what we started with. And let's see what else we have. We have 4 to the negative third power is 1 over 64. 4 to the negative third, which is 1 over 4 to the third, just to kind of remind you of what that means. 4 to the negative third means 1 over 4 to the third means 1 over 4 times 4 times 4 means 1 over 64. So I'll write all that down again. 4 to the negative third, 1 over 4 to the third, 1 over 4 times 4 times 4, 1 over 64. How do I write this as a logarithmic expression? Log base, the base of the exponential is the base of the log. Exponents on the other side, 1/64. So log base 4 of 1 over 64 equals -3. So looking at these, the one thing I want you to remember is we can write these things. The base of the exponential is the base of the log. And remember, if you have log base 10, if I just write log, that means log base 10.